back to Chemicals. Today I'll discuss about some more polynomial function, a little complex polynomial function, you can say it. So we'll discuss about it, and then we'll go through this curve. Okay, this is a simple potential curve. You already know about Lagrange potential. We'll come to this later. So at first, let me discuss about this type of function. Okay. So I already told you function like y is equals x square, x cube, x to the power 4, and this is a very simple function. You can easily draw this if you go through my videos, or not, but you can easily draw this. Okay. So what will be x square, and if you want to draw x cube like this, x to the power 4 like this also, x to the cube x to the 4. Okay, so this is not the motto. Today I want to draw about x to the power 1 by 2, x to the power 1 by 3, x to the power 1 by 4. What will be the curve? Okay. So let me first take x to the y is equals x to the power half. So I already told you, you already know this. You have to at first compare it with one of your known curve. And the very simple, very known function is y is equals x. So if you compare it with y is equals x, I am not writing too much. Okay. So if you just compare it with this, what will be the thing? X to the power half minus 1 is equals 0. Okay. So that will give you x to the power half is equals 0 and x to the power half is equals 1. So it will give you 0 again, and it will give you 1. Okay. So I am ready to point that is y is equals x to the power half is intersecting our curve, known curve y is equals x at x equals 0 and x equals 1. So if you want to draw, I am just drawing this plus positive coordinate. Okay, first coordinate. So this is my y is equals x. This is my y is equals x. So what you know, that is x is equals 0 and x is equals 1. This is my x equals 1. Let's just take this one. This is my x. This is the x axis. Okay. So now what we have to think, in this region from 0 to 1, what is going to happen? From 0 to 1, always x to the power half, okay, x to the power half is greater than x. Just simply take one of this, this is happening, okay. And from this region, x to the power 1, this region, x is always greater than x to the power half. X to the power half, that means 1 by 2x, so this is the case. So I am drawing this region. So what is x to the power is greater than, and in this region it is less than. Okay, so my plot will be like this. Okay, so this is a plot. But to draw like this plot, we really don't go through like this procedure. One thing you already must notice, that y is equals x to the power half. You can write this like x is equals y square. Just simply squaring the both. So you are getting x is equals y square. You already know y is equals x square. So these two functions are very much similar. You can easily get this by just exchanging your coordinates. Okay, by just exchanging your coordinates. So what I am telling, if you just put, okay, first clear these things. So I'm going to think, okay, this is yx at first. So this is your x square. Y is equals x square. Y is equals x square, and you just change this coordinate axis. So if you draw the same plot, now you are getting this plot, x is equals y square. Okay, so this is a simple thing, but you don't have to draw you have to draw this plot in one coordinate system. You can't exchange every time. This is a trick. You can do this. But one more thing, you can do it really easily. To draw like this curve, you just can take reflection about y is equals x axis. Okay, but you just have to take to draw like y is equals x square and y is equal y is equal x to the power half. Okay, that means x is equals y square. You just have to take the reflection of this curve, reflection of this y is equals x square along y is equals x. Okay. Then you will reach your this curve. So how? This is my y-axis, this is my x-axis. So what we know, this is my y is equals x square. And what I am telling now, you just have to take reflection along y is equals x curve. Just take it. So this part will reflect like, if this is your mirror, it will reflect like this, and this part will be like this. Okay. So what you get firstly, that is similar to this. So you don't have to go through this procedure. You just can draw it by looking at this function. So simply you can draw x to the power 1 by 3, x to the power 1 by 4. How? Yx, okay. X to the power cube 1 is equal to x cube, that will be like this. So what I am telling you, just take reflection along y is equals x. Just take in this part will be like this, and this part will be like this. So this will be your y is equals x to the power 1 by 2. If y is equals to x will be this. Okay. So similarly you can reach x to the power 1 by 4 also. X to the power 1 by 4 also. No problem at all. This is your x square. If this is x square, then x to the power 4 will be like this. I already discussed these things. So now I want x to the power 1 by 4. Just take reflection like erasing the x square. So what will be like this? Simple. X to the power 1 by 4. This is y axis, this is x axis. I'm not mentioning every time what is y axis, but this is standard convention. This is y, this is x. Okay. So we discuss about this shape. Okay. Now let me come to this functions. These functions are very easy functions. So in case of this also, you just apply your knowledge, known knowledge. Okay? You just have to compare it with y is equals to x. So if you compare it with then what you will get? X is equals 1 by x. Then you will reach x square is equals to 1. That means you will get x is equals plus minus 1. So this axis will cut your y by x at, if this is my 1, okay. Then here. Okay. Now you have to know 1, 2, 3. Your function is like this. So if your x goes to 0, okay, if your x goes to 0, then your y must have to go to infinity, because 1 by 0 is like. And if your x goes to infinity, then y will go to 0. So what I am getting, that intersecting 1 or plus minus 1, I am just taking the first quadrant, so 1 plus 1. And two things, if x is 0, that will go to x to the power, and x equals to infinity, then y is going to 0. So if we draw like at 0, it will be like this, and at infinity it will be like 0. So my plot will be like this. Okay. So x, y is equals to 1 by x. So this plot actually xy is equals to 1 or xy is equal to constant. This is actually hyperbolic equation. Okay. The geometry form is called hyperbola. So plot is very similar to this. So let me take one of very known function you already know. That is PV is equals to constant. Okay, PV equals constant. So if you want to draw P versus V, that means C. If this is C by V, or you want to draw C V versus P. And in both cases, this is like x is equals to 1 by, y is equals 1 by x like plot. So in both cases, you will get this plot. This P to V or like V P. You will end up with like this plot. This is very known function. Okay. So what you want to draw, like we already discussed about this. So now we want to discuss y is equals 1 by x square. Like, one thing, this will be like similar plot, but so to draw this we must have to compare it with y is equals 1 by x again. So what is my 1 by x? Like this. And if we talk about y is equals 1 by x square, then also if x goes to 0, y must have to go to infinity, and if x goes to infinity, y must have to go 0, and if we compare it with x, y is equals x, then we will get x to the, compare it with y is equals x, then what we will get? X cube is equals 1, that means one of the x is equal to 1, x is going to be 1. So this is very much similar like this function. So this plot will be like this only, but if we have to like compare it with, if we have to draw y is equals 1 by x and 1 by x square in same plot, so what we have to really think about. Okay, so let me just, I'm getting this 3 point. Okay, I'm just erasing this. So other information, one thing, in this region 0 to 1, okay, 0 to 1, just take x is equals half, left x is equals half. Then in this region x is less than, like x is less than 1 by x. Okay, in this region I'm taking problem. And let's similarly 1 by x square will be like x square will be 1 by 4. That means 1 by x square will be greater than this. So in 0 to 1, 1 by x will be less than 1 by x square. Okay, if this is 0, if this is 1. So in this region it will be greater. And x greater than 1, then 1 by x is greater than 1 by x square. So like this. So this will be y is equals 1 by x, and this will be y is equals 1 by x square. Okay, I think no problem in up to this part. So let me come to this sum of potential function. This basically represents potential in case of chemistry actually. So this is a very important function. Is a okay. So to draw this, I have to draw this photo. Let me take first this thing. Vx is equals x square plus x to the power 4. So to draw, what I'm telling to draw is like you know about one exponential and polynomial function like x to the power e minus x. You first have to draw like x, y is equals x and minus x, and then you have to think about that in this region this part will not be there, and in this region this part will not be there, so my plot will be like this. So a similar thing we must follow in this case also. So I'm drawing x square. Y is equals x square will be like this, x to the power 4 will be like this. Now if you take any point like x is negative or x is equals to, at 0 it will be 0, no doubt about it. But if any point is x equals to minus x, minus x 0 to 1, whatever, the function will be greater than both, like x square and x to the power 4, both will be greater than both. Just for check, you just take x equals 2. So x square will be 4, x to the power 4 will be like 16. So your function bx will be 4 plus 16, that's 20. So bx is greater than this, bx is greater than this also. So what will be your function? It will be greater than both of this. So this will be your function. This will be your function. First test. And here no chance of the curve will go. There's no chance that curve will go like in this direction, like in this or this. There is no chance because if whatever be your x, function is always positive. Okay. So let me take the second example. For the second example, we will see. The second example is x square plus x cube. Okay. So as you know, just draw. This is your x square. I'm again telling I'm not mentioning every time y and x. Pardon me for that, but this is my standard convention. Okay. X square. And what will be my x cube? This will be like, okay, no problem in that. So if x is greater than 0, okay, if x is greater than 0, and this part is y is x square, this is y is x square, and this is x cube. So when x is greater than 1, okay, then the function will be positive, and again the function will be greater than both this x square and x cube, because function itself is x square plus x cube. So in x greater than 0, it will be, if this is my 1 over, so this will be like up to this. And if x is less than minus 1, so the function, there is no part like this, but function will, as x cube in this region, x cube is greater than x square and x cube is giving you negative. That means the vx will comes to negative. So the vx will be like, sorry, this. Okay, and if x at what will happen at x equals minus 1, this point is something very interesting. At x equals to minus 1, your x square will give plus 1 and your x cube will give minus 1. That means at x equals to minus 1, the function will be 0. Okay, so if this is 1, so this will be like minus 1, this is minus 1. At this point, this is 0. That means from this point, I will get negative. So what about this part? From 0 to minus 1. Like minus 1 greater than x to 0. What will happen? In this part, x square is greater than x cube. Simply know this. In this part, from 0 to minus 1, in this part, x square will dominate over x cube. So the function will give you a positive result, and function will follow like x square curve. So the function will be like this. So my total function will be like, this is greater than x square x cube itself, and now come in like this, and like this. Okay. This is your minus 1, 0 point. So if I draw this plot, so what will be like this plot is? So if I do this, some like this. This will be minus 1 to 0. Must mention this point, because in this point the plot is something interesting. Okay. So this will be my plot. So let me come to the third plot. Okay. It is Vx is equals minus x square plus x to the power 4. So whatever my x is square and x to the power 4 will be always positive. But due to minus, the plot will change accordingly. Okay. So in this region 0 to x to 1, mod x will be greater than x to the power 4. I'm not taking the sign. Okay. In this region, x square will be greater than x to the power 4. Okay. So as minus is here before x square, so the Vx will give you negative in this region. Okay. And at like x is equals 1, at x is equals 1, at x equals to 1, that Vx will be 0, because this is 1, this is a 1, minus 1 plus 1, that is 0. And if x is greater than 1, then x to the power 4 is always greater than x square. So from 1 and onwards, the plot will be positive. At 1, the plot will be 0, but it will be giving you 0, and from 0 to 1, this will be like negative. So if I want to draw this, so what is my x square? I will draw the plot to plot. Like this is my x to the power 4, x to the power 4, and this is my, sorry, this is my, first draw this. This is my x square. This is my x square, this is my x to the power 4. So what will be my final plot? What I'm saying that this is 1. In this region, the plot is giving you like negative value, and after this is giving you like this will be like x to the power 4 plot. And the same thing will happen for this side also, because if we take minus 1, like minus of whatever, x is a negative quantity, then also x square and x to the power 4 will give you positive. But due to minus sign before x square, the plot will dominate up to minus 1. The plot will be like this again, same, and this. Okay. So this will be your final plot. Same. This is 1 and this is minus 1. Plus 1, use minus 1. You know, if I put minus 1, then will also be Vx is equal to 0, and if I put 1, then also Vx will be 0. So this plot, this is a very interesting plot. There's 2 hump is there. Okay. So this plot is known as double well potential plot. In case of potential, I'm talking about potential. Double well potential plot. Okay. Because 2 well is there. So now I want to draw like I want to draw this plot. Minus x dx plus 1 by minus x plus 1 by x square. So you know what y is equals x is 1 by x and y x square. So this will be like, oh sorry. This will be your y is equals x square, and this is minus x, and this will be like this, y is equals minus x. So what will be my final plot? Okay, sorry. My final plot will be like at let me just come to one point. If I take x is equals to 1, x is equals to 1, Vx will be 0, because this is 1 minus 1 and this is 1. So at x equals 1, Vx will be 0. Okay, so this is my 1. And as you know, from 0 to x to 1 in this region, in this region 1 by x and 1 by x square. Literally follow this type of equation. Okay, just take 1 x is equals half, then 1 by x will be like 2 and this will be like 4. So this in this region the relation will be like this, and after x is greater than 1, okay, x is greater than 1, then x is greater than 1, then your 1 by x will be greater than 1 by x square. 1 by x square. This is greater than 1, just take x is equals 2, then 1 by x will be half, and 1 by x square will be 4. So this relation is like that. So in this region this, and in this region this. So up to this region, as the function is dominated by 1 by x square, okay, so the function will always give you positive up to this. So I'm going like this. And after that, if we go x to the power x greater than 1, then it will always give you minus, because 1 by x is dominated over the function. So that means it will give you minus. So like that will follow like this. This will be my final form. In this region, this function is like this at x 0, and after this the function is like 1 by x. So my final plot will be like this. Okay. So I'll take one example from chemistry and I'll finish this video here. You already know about Leonard-Jones potential. In various topics of chemistry, these things have been discussed. In what that is telling VR, potential is a function of R. That is going to be 1 by r to the power 6 plus b by r to the power 12. And I already told 1 by x, 1 by x square, 1 by x cube. The functions are like very much similar to each other. Okay, like this is 1 by x, this is my 1 by x cube, this is x square, x cube, like this. So the function, all of these functions, 1 by x to the power n functions are like they are similar. So now if I want to draw this plot, I already told you that if I put this will be my like r to the power 6, 1 by r to the power 6, and that will be that 1. I'm just taking dotted because this is not my final curve. This is required to draw my. I'm not taking again a and b also. You just take the function will not matter because these are constants. So what will happen at 1 r equals 1? Okay, if I draw r as here. So at r equals 1, the function will give you 0 because minus 1 and plus 1. And in this part, the function will be behaving like positive up to 0 to 1. And after x is greater than 1, the function will be behaving like this. So this is my final plot. This will be my final plot. That is this function for this 1 by r to the power 6 plus 1 b by r to the power 12. Leonard-Jones potential. Basically, Leonard-Jones potential is like this term, this total term actually denoted intermolecular attraction, and this is intermolecular repulsion. Okay. So at which distance, which force will be dominated, that is basically determined by this potential function. Okay. So I think this is enough for today. And one more thing I want to share with you, that I'll stop here. After this video, I will not talk about any of the curves or like this. If you have any queries about graph, you just let me know in my comment box or like with a mail. I'll surely come up with an idea. If I with my like capability. Okay, so thank you.